now. Now, thank you for your attendance. This is Thailand International Mathematical Olympic Mock Examination 2020 to 2021 for Secondary 1 students. Now, this paper will have 5 topics, each topic with 6 questions. So we will be going through all 30 questions now. We're going through all 40 questions now. Okay, let's start with the first topic, which is logical thinking. Question 1. Given that A and B is of the ratio 1 to 1, A to B is of ratio 1 to 4, B to C is of ratio 2 to 3, C to D is of ratio 5 to 2, and A plus B plus C plus D is equal to 670. What is the value of D? What is the value of D? Now, this is a typical question for combining ratios, So now let's go to a blank pages. Use a sketch paper for us to do this. Okay. Now we have 4 different numbers. One is A. We know that this is equals to A and B and C and D. Right? We know that here. Now, also, oh, sorry. Maybe I just write it much bigger so that everyone can watch it very, very clearly. So now we have 4 different variables. One is A, one is B, one is C, and one is D. Now, according to our equation, now just go back to our question. We know that A to B is of ratio 1 to 2, 1 to 4. So let's write that down. A to B is of ratio 1 to 4. 1 to 4. Now, another piece of information is B to C is 2 to 3. So now we write that down. B to C is 2 to 3. Now we have the third bit of information, which is C to D is 5 to 2. 5 to 2. So we write that down is 5 to 2. So now, can we write a ratio such that all this could be combined into a single ratio A to B to C to D? Is it possible? The answer is yes, it can. Now, but it takes some time. It takes some time. Now we know that in order for B to C can be combined together, we need to let the 2 ratio on B which have the same number. They are now having 2 different numbers. We want them to be the same number. So we now try to multiply the second ratio by 2. We try to multiply the second ratio by 2. So we do something like this. So now the ratio of B for the second, now we have 3 different ratio given to us by the question. We want all this ratio who has the same number instead of different numbers. So we want the first and the second ratio having the same number. So now we need to multiply the second equation by 2. So now we make the first equation and the second equation, or both of them having B as 4. So now by combining these two, we get A to B to C is 1 to 4 to 6. Now because C is 3 times 2 is 6, right? So, but then we need to combine these two, right? Combine these two. One is 6, one is 5. How can we combine it? Of course, we now need to multiply that by the second equation must be multiplied by 5. The third one, let's see, oh, let's see, purple. The second one must be multiplied by 6. So in here, we also multiply by 6. But now, since we multiply the second equation by 5 for C, we also need to multiply the second equation by 5 for B. But if multiply the second equation by 5 for B, we also need to multiply the first equation by 5 for A, for the first equation for B. So also A need to multiply by 5. So by combining two together, we get our final answer. The final answer is A is 1 times 5 is equals to 5. B is 4 times 5, which is equals to 20. C is 3 times 2 times 5, or 5 times 6 is equals to 30. The last one is 2 times 6 is equals to 12. So the ratio of A to B to C to D is 5 times 20, 5 to 20 to 30 to 12. This is our ratio. Okay, this is our ratio. But we are not talking about this ratio just yet. We want to talk about if that's the case, which means that if A is equals to 5K for a proportionality constant K, so now B must be equals to 20K, C must be equal to 30K, and D must be equals to 12K. So now we know that A plus B plus C plus D must be equals to 5 times 20 times 30 times 12K. But this is equals to 5 plus 20 plus 30 plus 22 is equal to 67 times K. Right? But our equation have gave us that this is equal to 600 and it is equals to 670, right? So now what is K? What is K? So now we know that K must be equal to 10. So since we know that K is equal to 10, we can directly calculate all the corresponding numbers. Since now we know that A is equal to 5K, K is equal to 10. So A is equal to 5 times 10, which is equals to 50. So B is equal to 20 times 10 is equal to 200. C is equal to 30 times 10 is equal to 300. And D is equal to 12 times 10, it is equals to 1200. So now we get all our answer. Okay, so we get all our answer. So what is the answer of D? Let's go back to our paper. Do you still remember what is the value of D? The value of D is 12 times K, which is equals to 120. 120. This is our first question. This is our first question. All right. Okay, now let's go to the second question. Let's go to our second question. A, B, C, and D are passing ball starting from C and return to D for the sixth time. How many ways to pass a ball is or are there? Again, we need the help of some sketch paper. Again, we need some help from the sketch paper. So now we just clear up all the previous one. Okay. So from the question, we know that there are 4 people, A, B, C, and D, starting from C and return to D. So now we just draw A, B, C, and D. So this is the beginning, this is the first time, this is the second time, this is the third time, fourth time, 0, 1, 2, 3, 4, 5, 1, 2, 0, 1, 2, 3, 4, 5, 6 times. Okay. So now let's fill up. So this is A, this is B, this is C, this is D. Now here the first column which represents the initial state. Initial. All right. Oh. Okay, this is the first time. Okay. The first time we pass the ball, the second time we pass the ball, the third time, the fourth time, the fifth time, and the sixth time. The sixth time. So now because we start from C and then we end to D, let's write that down. Let's write that down. We start from C. We start from here and end to here. So write that down. So since we start from C, so that we get that only C will have the ball, will have a possibility to have a ball. All other students do not have a ball. So initially there's only C. So after first passing, we know that C can pass through A, C can pass through B, but C cannot pass to itself. So there's no possibility that after first passing, it will go to C. And then there's C can pass through D. So there's also one chance. Now the second chance is what it concerns us. Now, how about what's the possible combination of that A will receive the ball in the second time? Now we know that the ball can be passed from B to A or from D to A. So it will be 1 plus 1, which is equals to 2. 1 plus 1. Similarly, we know that the ball can be passed from A or D to B. So B is also equals to 1 plus 1 equals to 2. Now, the situation of C is interesting. Since the ball can pass from A to C, A to C, B to C or D to C. So there are actually 3 different ways for us to pass the ball from A to C, from whatever A, B, or D to C. So it would be 1 plus 1 plus 1 equals to 3. So there are 3 ways. So at the end of the day, D is also 1 plus 1 is equals to 2. After knowing this, and we can do the same thing in the first parsing, right? The first parsing, we know that, we know that there's only B or D which can pass to A. So, but now this time is C is also possible. So it should equals to 2 plus 3 plus 2, and hence our answer would be 8. And then we know that B is also 8. C is just 6 because it is 2 plus 2 plus 2, right? It is equals to 2 plus 2 plus 2. So just 6. Oh, yes. Yes, thank you. Yeah, make some silly mistake. Yeah, this is actually 7, not 8. 7, not 8. So this is 7, this is 6, and this is 7. Again, we can keep on writing about this. And then the fourth one, it will be 7 plus 6 plus 7, which is equal to 20. Is also equal to 20. Is it equal to 21? Is it equal to 20? And then again, we get this is equal to 60, and all other is equals to 61, 61, and 61. And hence the last one would be coming from A or B, A or B or C, right? So it must be equals to 61 plus 61 plus 60. So the answer would be 182. 182. So this is our answer. If we start the ball from player C, then after 6 passing, there are actually 182 ways for us to pass it to D. 182 ways for us to pass it to D. This is our answer. Let's write that down in our mock examination paper. So this answer should be equals to 182. This answer should equals to 182. Now, question 3, right? The white chopstick, the yellow chopstick, and the blue chopstick are mixed together. If you want to get 3 pairs of white and 2 pairs of blue, how many pieces of chopstick are needed to be taken? Now, what is the worst case scenario? Every time it asks you the least amount, think of the worst case scenario first. Every time it asks at least or any other simulacrums. For example, like the minimum or the maximum or the most or this thing. So think about the worst case scenario. What if we are going to pick all the maximum number of chopsticks such that this line is not true, such that this line getting 3 pairs of white chopstick and 2 pairs of blue chopstick. This line is not true. This is not true. How can we do this such that this is not true? So which means that we can at most pick 5 white chopsticks, right? 5 right chopsticks. As long as we just have 5 white chopsticks, and we are fine. Because no matter how many blue chopsticks, how many yellow chopsticks we get, as long as we do not get 3 pairs of white chopsticks, the situation is not satisfied. So the worst case scenario, which is equals to the situation is that the yellow chopstick, we pick up all the yellow chopsticks. How many yellow chopsticks are there? How many yellow chopsticks are there? It is 28, right? We pick up all 28 plus, or we pick up all worst case scenario. This is difficult to think. Might be even worse. Now, worst case scenario, we consider two situations. The first one is that when we pick up insufficient worst case scenario, first one and second one. The first one is insufficient blue, insufficient blue. I don't know why I get all cap in this cases. Why is all cap? I don't need all cap. Okay. Okay. Insufficient blue. If we have insufficient blue, then actually how many blue chopstick can we take? Because we need to take 2 pairs, so which means that we can only take 3 of them, 3 chopstick, which is blue. But then we can take all those chopsticks out. For example, we can take white chopstick, all this 22 white chopstick out. And also the yellow chopstick, 28. So this means that it actually have 3 plus 22 plus 23, which is equals to 52. The second situation, which can also be a worst case scenario, is insufficient white. In this case, we can only take at most 5 white, but we can take all other blues, which is 14 plus the all other yellow, which is okay, 5 plus 14 plus our yellow one, which is equals to 28, which we then will get 2, which is 42, 47. Okay. Yes, 3 pairs of white. Yes. Supposed to be 6 plus 22 plus. Now, remember, the first case scenario is we do not have sufficient blue chopstick to form 2 pairs. It should not be 6 plus 22 plus 28. Why? Because the blue, we need only 4 of them. We need only 4 of them. If we have 4 of them, we satisfy this situation. We don't want it to be satisfied, so we just take 3. But 3 pairs now, 3 pairs is the is the second case. The second case. 3 pairs is the second case, is this case. 3 pairs of white chopstick, yes, sure. It's that 3 pairs. So if we have 3 pairs, then we will be good, right? If we have 3 pairs of white chopstick, we will be good. We don't want it to be satisfied, right? We don't want it to be satisfied. So we just take 5, just one less than 3 pairs. So we have 5. After we take this 5, we can no longer take white chopstick. So we can only take all blue chopstick, which is 14, plus all the yellow chopstick, which is 28. So if we have insufficient blue, we can take 52. If we have insufficient white, we have to take 46. Which one is bigger? Of course, it's a 32 is 52 is bigger, right? So we know that the worst case scenario is actually 52. Which means that we can actually take 52 pairs with 52 chopstick, and we do not get 3 pairs of white chopstick, and we don't get 2 pairs of blue chopstick. So what do we need in order to guarantee this will happen? Because we know that the worst case scenario is the worst of the worst. It cannot be worse if we take even one more. If we take even one more. So we just add it from 1, and then we get our answer, which is 33. William Lim, is that okay for this question? Is that okay for question 3? Yes, it is. It's 3 times 22 times 23. Oh, yeah, sure. Yeah. Yes. I have mixed so much computational error. Yes, this is not. Yes, you are correct. This is not 52. This is 53. Yes, you're correct. So the worst case scenario is equals to 53. So the best case, so we need to add one more in order for this to be to guarantee that this must happen. So the answer is still 54. Yeah, sure. Good job. Yes, the answer is 54. Because we know that if with insufficient blue, we should be taking 3 blues, 22 white, and 28 yellow to form a 853 chopstick, which does not satisfy our situation, satisfy our question. So we need at least one more, which brings it from 53 to 54. Are there any questions for question 3? Are there any questions for question 3? The answer is 54. Now, if no, now we will go to question 4. According to the patterns we shown, what is the number in the blanket? Now, what exactly is the pattern? Every time we study this pattern, we will be reminded that it's better for us to start by studying their differences. Now, in here, we know that 2 and 6 is difference is 4. 6 and 14, the difference is 8. 14 and 30, the difference is 16. And for 13 to 62, the difference is 32. If you just look at the differences, difference of adjacent number, can you spot the pattern? You will see that all this number is actually a multiples of 2. It is 2 times 2 is 4, times 2 is equal to 8, right? If we times 2, 4 times 2 is equals to 8. 8 times 2 is equals to 16. 16 times 2 is equal to 32. 32 times 2, which probably would be our next difference, which is 64. So now we can guess that because it satisfies all this equation, we know that it probably satisfies equation. The answer should be 1 to 6. The answer should be 1 to 6. This is of question 4. Okay. Now, question 5. Mary go east for 40 kilometers and then go north for 13 kilometers. How far is she now from the original position? So if we draw Mary, initially Mary is in here. So she goes east 40 kilometers, and then go north 15 kilometers. So it goes to here. Now, there's many things that we can talk about. One thing is that it is actually a perpendicular angle. And also this is 14, this is 13. And it reminds us a very common triangle with a common right angle triangle with 3 sides equals to 3, 4, and 5, right? So we know that this length, which is equals to 40 squared plus 50 squared, and then its square root would be equals to 50. So we know that the answer must be 50 because this is exactly equal. By Pythagoras theorem, we know that this is 40 squared plus 30 squared, and take the square root of it. This is question 5. All right. Now, let's go to question 6. Find the average of the following sequence. Now, again, if we've seen a lot of numbers, again, we ask, what is the difference in addition numbers? We want to find the pattern first. So now, in here, we know that these two numbers, the difference is 4. Two addition number, difference is 4. Two addition number, difference is 4. Addition number, difference is 4 and 4. So this is actually a arithmetic sequence. For arithmetic sequence, the average, we know that the average is equals to average is equals to total divided by number of terms. Right? So what is the total? Total, we know that for a arithmetic sequence, the total is equals to the first number plus the last number times the number of turns divided by 2. So if we substitute this total into our average, then we get our final answer. Average would be equals to the first plus our last and then we will divide them all by half. Notice that now, since the number of terms it has been canceled out, we do not need to calculate it. We just need to calculate, we just need to substitute the first number, which is 1, 2, 3, the last number, which is 3, 2, 3. So the average is equals to 1, 2, 3 plus 3, 2, 3 equals to 4, 4, 6. And then when we divide by 2, so the average is equals to 2 to 3, 2 to 3. All right. Now this is our first 6 question. First 6 question. Are there any questions of it? Are there any questions for it? If no, then we will go to our next part. We will go to our next part. Algebra. How many integral solutions, integer solutions, are there if -8 is greater, is more than like 4x plus 16 is more in terms more than 82. So now we're just doing a reduction. We know that there is a term which is of 16. We don't want it. So let us minus 16. We want to get rid of it. But if we want minus 16, we need to minus 16 on both sides. Or in certain way to say it, 3 sides. If we minus it, then we get that minus 8 minus 16, which is equals to minus 24. Minus 24 is actually smaller than 6, but it is all smaller than 4, 6. But it is also 4, 6 is in terms more than 82 minus 16, which is equals to 66. All right. So we just divide them both sides by 4. So we know that x must be when negative 24 is divided by 6, it is equals to 4. So we know that x must be greater than -4, but it must also be smaller than 60. And since it is 66 divided by 4, which is equals to 16 and a half, 16 and a half, which means that it is actually equal smaller than or equal to 16. So how many integer number? So we know that x can be from -3 to 16. So in here, there is 12, 20 numbers. Oh no, it is not 20. It should be, since it cannot be equal to 16. Divided by 4 is, oh yes, again, stupid, again, stupid arithmetic programs. Yeah, sure. Yeah, I just wonder. I just wonder, this is not the same as what I've done before. So it is more than or equal to 16. So it should be actually from -5 to 16, which is equals to 22. And 22 is our answer. 22 is our answer. All right. For question 7, 22 is our answer. Okay, factorize it. there's not much to talk about when factorizing. I'm sorry, but can leave for around 5 because I do something. Oh, yes, of course. Well, for any student that if you want to take a break to go to bathroom or whatever, you can leave, of course. But be reminded that we will not stop and waiting for you. So please do it in a hurry. Now for factorization x squared, so this is really nothing to talk about. We just know that since we know that if there is two answers from here, from Readers theorem, but Readers says that this two number must be of a difference of 1, and one must be greater, one must be smaller. The larger magnitude one must be negative. So we know that this must be equals to x minus 8 times x plus 7. Now, there are many different ways to do this. We will later on talk about completing squared or even quadratic formulas, but now, since we are still secondary 1, we will delay it until secondary 2. So the answer is x minus 8 times x plus 7. Yes. Hugh, you are correct. Because the answer is 16.5, which means I can include 16. Unlike the cases for 27 at -6, we cannot include -6 because it is a clear division. So we know that our x must be greater than -6. All right. Now, so we go to our next question, which is question 9. Question 9. Question 9. Find the value of x if this is true. We can simply just delete the parentheses, right? So this is 5x, and then we negative 8x. Now, since the negative of negative, the reverse of it is plus, so it's plus 14, and then we plus 4x, and then we minus 37, which is equals to 0. Which is equals to 0. Then we just combine all terms, 5 minus 8 plus 4, which is equal to 6, right? Which equals to 6. And then it's 14 minus 36, which is equals to 43. So x minus 43 is equal to 0, and hence x is equal to 43. X is equal to 43. This is our question 9. This is our question 9. It's very simple. We just simplified it. We just take out the parentheses. This is actually a question about on primary 3 or 4. Primary 3 or 4. If it is pure numbers. Now, since we are getting some unknowns, it would be a little bit more difficult, but it's not much different from average arithmetics. So now let's go to question 10. So now let's go to question 10. We know that A and B are real numbers satisfying this equation. A minus B equals to 4, and then A times B, which is equals to A times B is equals to 8. Find the values of A squared plus B squared. Now, this is actually very useful so that's something that I would like to talk about in secondary 2 or secondary 3 when we talk about something called the Readers Theorem. And we'll mention something like this in question 8, but we do not talk about what that is. Later on in secondary 3, especially in high school, then we will talk about something very similar to this equation. Now, the way to do this is we notice that in order for us to get square, in order for us to get square, we need to square this. We need to square this. We need to take the square of a minus b. Since a times b, we do not get a square, right? So in order to get the quickest way to get a square is to just square it. But if we square this term, we know that this will be equal to a squared plus b squared, and then we minus 2ab, right? But this, according to our equation, this must also equal to 4 to the power 2, which is equal to 16. But on the other hand, it is equals to a squared plus b squared. Since a times b is equal to 8, so this is negative 2 times 8. So this must be equals to negative 16. So this is 16. A squared plus b squared is minus 16 is equal to 16. So what is this? This must be equals to 16 plus 16, which is equals to 32, which is equal to 32. So this is our question 10. This is our question 10. Question 11. Question 11. Find the sum of possible value if x plus 3 plus x minus 2 is equal to 11. Now this question actually have many different ways to do this. Now we are now doing the most rigorous way. Now this is not the fastest, but this is the most rigorous. Why we do this is because we will reserve for the higher levels to talk about the fast way. Now, because in this two, what exactly is this symbol? What exactly is this two symbol? This is equals to absolute value. We just for all, no matter what values within these two numbers, for whatever values within these two numbers, we just take its magnitude. We do not take its size. For example, if x is smaller than negative 3, so x plus 3 is equals to negative. Even then, we will just give it a negative sign to change it from a negative number to a positive number. So in that regard, every pairs of absolute values, there's some critical numbers in here. The critical numbers is equals to 3, negative 3. The other critical numbers is equals to 2 because at the critical numbers, their behavior is changed very rapidly. So for these two irregular numbers, two critical numbers, we can get three different quadrants. One is x is actually smaller than negative 3. One is x is actually equal to negative 3 and negative 4. Oh, okay. So it is more than 2, but is all so greater than negative 3, greater or equal to negative 3. And the last one must be x is greater than 2. Now, in these three separate cases, we can simplify this equation. The first equation, when all of them will be equal to negative, then the first equation would be equals to negative x, negative 3, negative x plus 2, which is equals to 11. So we know that negative 2x must be equals to 11, or x is equals to 5.5. Oh, I'm sorry. I make a silly mistake again. This is not 3. Oh, stupid me. Keep making stupid mistake. This is +2, should be +2. So if we rearrange it, we then get -2x equals to 12. So that we get x is equals to -6. So this is, and -6 is more than -3. So this is our answer. This is one part of our answer. One part of our answer. Now the next part, x is within 2 and -3. So then we know that the first one is positive while the second one is negative. So we get x plus 3 minus x plus 2 equals to 11. But then for all the x, x plus 3 minus x plus 2 equals to 11. Right? Equals to 11. But this will result in 5 is equals to 11, which is impossible, right? Which is impossible. So we need to cross them out. So there's no answer within for x to be within 2 and -3. So at the end of the day, there's still x is greater than 2, then result would be x plus 3 plus x minus 2, which is equals to 11. So in this case, it's 2x, which is equals to 10. So x, which is equals to 5. So x will be equal to 5. That is the way to calculate it. So we know that the possibility values of x must be equal to -6 plus 5. Hence all the possible value must be equal to -1. All possible values equals to -1. So this is question 11. Question 11. Okay, so find the values for this equation. Now we will do question 12 as a substitution by using substitution. Now we know that by noticing x, one is 4c, the other is 6c. So there are common factors, right? We can expand it into our least possible multiplier and multiples, not multiples. So if we now multiply the first equation by 3, and the lower one multiplied it by 2. So this is multiplied by 3, then we will get 12x plus 9y, which is equals to 18. So the lower one would be equal to 12x minus 14y, which is equals to 62. Now we get these two equations. Now this may be, can you tell me how you get -3? How good -3? No, all right. Now please bear with me. After I explain question 12, we will go back to question 11. We will go back to question 11. Now we now get two equations. One is this, and the other is this. Notice that these two equations they both have 12x on its one side, on its left side. So we can deduce them together. So now the left hand side, 9 minus negative 14, which is equal to 9 plus 14, which is equal to 23y. But the right hand side is 18 minus 62, which is equals to negative 46. So and by this we get y is equal to negative 2, and then we substitute it into this. We know that 4x minus 6 is equals to 6. Hence, we know that 4x is equals to 12, and then x is equals to 3. So we know that in here, since x is 3, y is negative 2, so their multiple x, y must be equal to negative 6. Is that okay? Now, if everything is okay, I will go back to question 11. I'll go back to question 11, and then we'll talk about it. We'll talk about it now. Now, someone asked me that how can we get negative 3 and plus 2? It is actually closely related to the definitions of absolute value. What exactly is that absolute value? What exactly absolute value? What exactly does these two lines mean? It simply means that if we get an absolute value of whatever numbers you have within, if this is greater than 0, then it would be equals to x itself. This number would be equal to x if x is greater or equal to 0. But this number would be equal to negative x if x is smaller than 0. So now let's go back to question 11. Immediately we know that the most important part of absolute value is whether or not it is positive or negative. So in here, how can we decide whether it is positive or negative? It is by x minus 3 is equal to 0 on the boundary, right? On the boundary. So we know that negative 3 is the most important point, because when x is negative 3, x plus 3 is equal to 0. Again, the next part for x minus 2, again, we know that when x plus 2 is equal to 0, is equals to plus or minus 0, this will be changed a lot, because one is x, one is negative x. There's a negative sign carried around this equation. So we need to know when would it become 0. That when is actually 2. So this is how we come up of plus 2 and negative 3. Because by drawing the graph, we are dividing the whole number lines into 3 different parts, all of which the equation, the absolute equation of absolute value will behave differently within different parts. So we need to do this. We need to separate all different parts, and then we eliminate this the positive value sign, the absolute value sign. All right. So this is 1 to 4 to 12. 1 to 12. So now let's look at, hello, can you hear me? Hello, can you hear me? Sometimes it stops. Okay. So now let's look at the question 13. Number theory. Find all the number or positive integer numbers of this. Now we know that if we want to find a positive integer number, at least we need to know what is actually the prime factorization of this number, right? What's the prime factorization of this number? So we know that it actually is equals to 2 times, oops. Okay. Let's use a brighter color. So it is equals to 2 to the power 2 to the power 2 to the power 3 times 2 to the power 3 times 3 to the power 3 to the power 3 times 7. So if you write that down, it will be like this: 2 to the power 3 times 3 to the power 3 times 7 to the power 1. So the number of factors, we know that by equation, we know that we can then immediately write them down the number of factors, which is equals to 1 plus the exponential and then multiply them all together, right? 1 plus 3 times 1 plus 3 times 1 plus 1. So this is exactly the number of factors. So in here, we know that this is 4, this is 4, this is 2. So the number of factors are 4 times 4 times 2, which is 32. 32. Now, okay, question 40. Question 40. Now, find the unit digit of this. Now, this question is formidable on sight, but it's actually very simple if you think about it. Now, all these numbers for a 1 to the power 1 times plus 6 to the power 2 plus 11 to the power 3. Now, we can divide all this number into two groups. Divide all this number into two groups. One is all the number with 1 as its last digit. We know that since it has 1 as its last digit, all this number is actually 1. Because we know that for the smallest digit, it does not affected by tens or thousands or hundreds, whatever. But it's only affected by the smallest, it's the least significant factor, which is the 1. And 1 multiplied by everything, multiply no matter how many times to itself is also equals to 1. Another one that is very similar is this, is the 6. Now we know that it is 6. We know that again, 6 to power of whatever, it is also equals to 6, right? No matter how much power it has of 6, it was all going back to 6. So this equation is just asking you how many 1 and how many 6. We know that for every 1 and 6 pairs, that actually goes from 1 and 6 to 61 to 66. So there are actually 8 different cycles. 8 different cycles. So at the end, it should be 7 times 8, which is equal to 56. Which is equal to 56. Okay, so now let's go back to let's go to question 15. When a three-digit number is divided by 8, 6, and 3, the remainder is 1. What's the maximum possible value of these three-digit numbers? Now, just a reminder, divisible by, when a number is divisible by 6, it automatically means that it is divisible by 3. It automatically means that it will be divisible by 3. So actually, if you think carefully, you don't really need to think about the last part. When a three-digit number is divided by 8 and 6, the remainder is always 1. If a number divided by 6 is the remainder is 1, it divided by 3, the remainder is always 1. There's no exception. Because 6 is the power, is the number, is actually a multiples of 3. So now, what's the maximum possible value of this maximum number? Hence, we are now talking about a number which can be divisible by 8 and 6, which that number we will call it the least common multiple, which is the least common multiples of 8 and 6, which is equal to 8 times 3 or 6 times 4, right? Which is equal to 24. So when a two-digit number is divided by 26, we actually know that the remainder is equal to 1. So let's find a maximum possible value of a three-digit number. What's the maximum possible value of a three-digit number? Now, how about 999? This is best. This is the best, right? This is the largest number. And then we divide by 29. So we get this is not 2, this is 4. We'll get 96, and then we get 59. 96. 96, this is equals to 59, and then we get 1, and then we get 24, and we will get 15. So in order for it to have a remainder of 1, so it needs to be added, it needs to be subtracted by 14, right? Subtracted by 14. So we know that this number must be equals to 999 minus 614, which is equals to 985. So this is the biggest number that we can get, such that all 8, 6, and 3 divided by that would equals to 1. Which is equals to 1. So now if we do not have any questions, we will go to question 16. Question 16. The difference between 2 square is equals to 153. The difference between 2 square is 153. Now, what is the smallest value of this? What's the formula of the numbers of factors from Q13? Oh, okay. Okay, now, okay, before we talk about question 16, let's go back to question 30. Now, there are students that ask me what is the formulas of this equation. Now, the formulas is difficult to be write down, but it is very easy to remember it. Now, suppose that this number is actually 2 to the power 3 times 3 to the power 3 times 7 to the power 1. Okay, so the formula, the number of the number of factors is simply we take all the exponential, that is the blue number, the exponential down, and then each of them, add 1 to each of them, and then multiply them together. So the number of factors would be equals to 1 plus something, and then 1 plus another thing, 1 plus the third thing. All right. So if we write that down, we just need to add back all the numbers into it. It should be number factor is 1 plus 3 plus 1 plus 3 plus 1. We just put all the, if we prime factorizing our numbers and then we put all the exponential of these prime factors into this equation, we just add it by 1 and then multiply it together. Now in secondary 2, we will explain it. So don't be, now I think some of you might already know the answer exponentially, but not. I'm sorry, because I do not have enough time, so I cannot explain the reason behind this equation, because it takes some time to explain it. So let's go back to question 16. Let's go back to question 16. Now, if there's two, now let us say that those two numbers is a square and b square. A square and b square. So these two numbers is a square numbers, right? These two numbers is a square numbers. Now, what is the difference of it? Let's write that down. Let's write that down. So the difference must be equals to a to the power square minus b to the power square. But actually, what does that mean? What does that mean? It actually means we know that there's a formula for this kind of difference. We will know that this is actually equals to a minus b times a plus b times a plus b. So in here, we know that a squared minus b squared is equals to a minus b times a plus b. So now we know that this two number must be a factors of 153. All right, then we can study all the factors of 153, and then we will get answers. But not so fast, since we know that if we know if we know a minus b, if we know a plus b, so a, what exactly is a? A is actually equals to a plus b plus a minus b, and then the whole thing divided by 2, right? So since the things that we want to be minimized is actually equals to the sum of these two factors. The sum, what is the situation that the sum would be smallest for a constant multiple? The sum is the smallest if and only if the sum is the smallest if and only sum is the smallest if and only if a plus b is close to a minus b. If only if these numbers are close, these numbers are roughly equal. So now let's look at 153. 153, what exactly is it? 153, if we can divide by 3, then we get 51, and then 51. So this is 3 times 51. Then if we divide by 3 again, we will get 17, right? So the closer way to write that down must be equals to 9 times 17. And we know that since a plus b must be the bigger one, so we know that a plus b is equal to 17, a must be equals to 9, so a is equals to 17 plus 9, which is equal to 26, divided by 2, so a is equals to 13. So we know that the bigger number must be equal to 13 squared. So it which would be equals to 169. 169. Okay, the number is equals to 169. Okay, so the next question would be our question 17. Question 17. How many? No, this is a very, very important question. But the answers can be easily explained, but it's difficult to make it rigid. Now, to make it solid, because it's difficult to prove, but it's intuitively very easy to understand. So now, if we have a fraction with a denominator of 2020, how many simplified fraction with a denominator of 20? Now, let's write that down. Write this down. Now, there is something on the top of 2020. But this is the most simplified, which means that it has no common factor with B. So A has no common factor with 2020. Has no common factor with 2020. All right. Now, but we know that 2020 has many factors, including, because it is equal to 220 times 101. 101 is itself a factor, and hence it is equal to 2 to the power 2 times 5 times 101. So now, so it has a factor of 2, it has a factor of 5, it has a factor of 101. So A does not have 2, does not have 5, and does not have 101. So now, how many numbers of which there's no factor of 2, no factor of 5, no factor of 101? The easiest way to do this is by considering that because for this 2020 number, half of them actually has a factor of 2. Those are the even numbers. So we, at the very beginning, we just consider the odd number. So given that 2020, if we want to cross out all, all two factors, we cross out all two factors, what we remain is 1010. So now we want to cross out all factors of 5. How many factors of 5 within 1010? It should roughly be 1010 divided by 5, which is equals to 202. So we need to cross out 202 of 1005, and that what we remain is 808, right? Now, here is the problem. Here's the problem why it's difficult to prove it, to make sure that it is true. Because once we cross out all the even number, is this possible for you to say that for every 5 odd number, there is one number which is of multiples of 5. Can you say that? The answer turns out to be yes. The answer turns out to be yes, because 2 and 5 is relative prime. But this is very difficult to prove, and it related to something which we call the Euler's find function, which we will not go to this so deep. We will talk about it in high school, in the senior secondary school. But just keep in mind, we roughly we can just divide them. For no matter what, how many numbers, as long as they are following a particular pattern, particular arithmetic series, then you can consider it as just as if it is from 1 to 1010. And we divide by 5 and get all the numbers. We get how many numbers of it, which is of a factors of 5. Now, at the end, we need to cross out all the factors of 1001. So for these 808 numbers, there is roughly divided by 101, which is equal to 8. So it should roughly have 8 number, which is of a factor of 101. So if we minus this 8, so we get 800. And that 800 is because we have crossed out all the factors of 2, 5, and 1001, which is all a factor of 2002 and no other factors, right? So these 800 numbers are, they all have no common factors with 2020. So the answer is 800. This is exactly these 800 numbers, because we cross out all the numbers from 1 to 2020, all the numbers which have a factor of 2, which have a factor of 5, and which have a factor of 1101. Okay? So the answer is 800. Now let's go to question 8. So if 8, now this is a very fancy way to say a very simple. This is a very fancy way to say a very simple result. It simply means that modulator, it simply means that x when it was divided by, when x is divided by, let's write it down. When x is divided by 13, it has the remainder of 8. It's just as simple. When x is divided by 13, it has a remainder of 8. So let us ask the following question. Let us ask the following question. If this is a 4-digit number, let us understand it's 1000. 1000 is the smallest 4-digit number, right? It's the smallest 4-digit number. So if we divide it by 13, what would be the result? If we divide by 13, what would be the result? The result would be, so this is 7. So this is 91, and then we have 9 left. We have 19, so this is 6, and then we have 78, and then we have 1 left. But now, no, oh no, it should not be 1 left. It should be 8 left. So we need to add 7 to it. We need to add 7 to it. So the smallest number must be equal to 1007. It's just like this. Sorry. Because the remainder is not, the remainder is not it's not 1, but it's actually 12. Actually 12. So now if we want to get a remainder of 8, so we need to minus we need to subtract 4 from it. But oh no, if we subtract 4, then the number we get will no longer be a 4-digit number. So it would be equals to 996. So the smallest number should be 996 plus another 30. So then you will give us the result. The result would be 109. This number, when it was divided by 13, it will give you a remainder of 8, because 1001 is actually divisible by 13. All right. So this is the answer. Now, if you have an answer sheet, you will find that this is not the same as the one that was marked down in your answer sheet. Your answer sheet is wrong. 1001 is divisible by 13. So it will not remain 8 there. So the true answer is 1009. 1009. All right. So now let's talk about geometry. Now, okay. So in here, we have a 9. We have a 9 from 7 to 8. To have 9, something like this. So we know that this point is our A. This point is our B. And the middle point is our M. We know that since the x coordinate must be, the x coordinate of M must be the average of the x coordinates of A and B, right? The x coordinate of M must be the median or the average of x coordinate of A and B. So, but A is 8. So what? Oops, this is not A. This is A. And this is B. So we know that it must be the average of the number 7 must be your average of 8 and some number. What is that number? Such that 7 is the average of 8 and that number. That number must be 6. So we know that x is 6. And again, if we are looking at the y coordinate, the M must be the average of the average of the y coordinate of A and B. So 1 is 9, 1 is 3, so the average is 6. So we know that my is 6. So both of them are 6, so that we know that this number must be 12. This is 19. Very simple. Coordinate geometry is very simple in secondary 1. In secondary 1, it's usually the simplest method, but after we go to secondary 2 and 3, after we learn many things about the trigonometry, then it becomes very, very hard. All right, so now let us go to question 20. In a rectangular n-side polygon, the interior angle. Now let us draw let's say a pentagon, a regular pentagon. Not quite regular, but what exactly is an interior angle? This is our interior angle, right? This is our interior angle. Now, how about the exterior angle? Exterior angle is this one. If we extend the line, this angle is our exterior angle. This blue angle is our exterior angle. So in here, we immediately know that the interior plus exterior, we immediately know that interior angle plus the exterior angle must be equals to 180. But we also know that according to our equation, interior angle minus exterior angle, which is equal to 151, which is equals to 135. So immediately we can deduce the exterior angle. What is the exterior angle? Exterior angle, which would be equals to 180 minus 1.5, and then it will be divided by 2, right? So this is actually equals to, if we might say it's 55 divided by 2, which is equal to 27.5. 27.5. But we know that this, since we know from geometry, we know sum of all exterior, which is equal to 360, right? But what is sum of all exterior in this case? Sum of all exterior must be equals to n times our 27.5. So it must be equal to 360. So we now then know that n must be equals to 360, 6,000 divided by 275, and hence it will give us our answer, which is equals to, oh, did I make, oh, geez, I keep making mistake. This is not 275, because this should be minus it is equals to 45 divided by 2, which is 22.5. Geez. So this is not like this. So this must be n times 22.5. Yes. Thank you. It is equals to 13660. So then we know that n must be equal to 16. We just divide both sides by 22.5, and hence it is 16. Okay, Justin, thank you. Thank you very much. This is question 20. Is there any questions? Question 20. All right, let's go to the next one. Now this is actually difficult. This is a difficult, but it is also a very good cases to study. Now we have a triangle which is of sides 21, 28, and 35. But hope that everyone catch that it is 21 square plus 28 square, which is equal to 35 square, which means that according to Pythagoras theorem, this is actually a right angle triangles. This is actually a right angle triangle, and with area equals to 21 times 28 divided by 2, which is equal to 21 times 14, which is equal to 294. Okay. Now, why we will calculate this area? Of course, because we want to calculate the area of the shaded region, right? I'm sorry, I cannot scroll to the English question, because if I scroll into there, then I cannot see the graph. So let's bear with me. Let's listen to my speaking. Now, but this is a circle, and a circle that touches the triangle. What does that mean? Yeah, the radius. How can we calculate the radius? There are many ways to calculate it, because we can now Yes. Since say that it is the radius is equal to 7. Why 7? How can we be so sure that it is 7? Why 7? This is a good question. It might not be 7. Now, let us find out how to calculate. Because from the center of radius, and then we drop 3 nines. These 3 nines must all be perpendicular to the three sides, because this is a radius that touches the three sides. All right. But then by this, we can divide the whole triangles. We can divide by the whole triangles into 3 different smaller triangles, like this. If we divide it by this, and we know that the radius is equal to r, for example, r. So I would like to ask, what is the area of this smaller triangle? What is the area of this small triangle? It has a length of 21 and a height of r. So this triangle has an area equals to 21 times r divided by 2. So how about the next one? How about this one? What is the area of this one? Again, it has a length of 28 and of height r. So this one has a area of 14 r. And the last one, the blue one, this one, what is the area of this triangle? What's the area of this triangle? It has of length 35 and of height r, again r. So we get it is 35 per r divided by 2. So these 3 triangles added up together must be equal to our 294, right? So let us add all this together. If we all add all this together, we will go to our leftmost, which is equals to 21 divided by 2 plus 14 plus 35 divided by 2, and then the whole thing multiplied by r, which is equals to 294. This one, 21 plus 35, which is equal to 56, which is, and divided by 2, which is used for 28 plus 14, which is equal to 42. So 42r is equal to 294. So what is the radius? The radius should there be 7. Exactly like Sensei. So if we know the radius, then we can calculate the area of the circle. What is the area of the circle? Area of the circle, which is equal to pi 22 over 7 times square root of 7, which is equal to 154. So our area will be equals to 294 minus 154, which is equals to 140. 140 is our answer. Now, the most important part of this question is not really about how to calculate the shadow part, but knowing that how to calculate the so-called inscribed, the radius of an inscribed circle. This is an inscribed circle, the circle that is bounded by this triangle. This is by separated it into 3 parts and calculated the areas of the 3 triangles separately, and then combine it to make it so that it is equal to the area of the whole triangle, we can calculate the radius of the inscribed circle, right? So the answer is 140. All right, so next. This is actually a very simple this is actually a very simple. This is not about geometry, but it really is just a pattern matching. It's just a logical thinking, right? So if we write them all down, then immediately seeing something very interesting. If it is the first, the largest number start from 2. If it is the second, the largest number start from 3. If it is from third, the largest number start from 4, and then it will go down, right? So the 14, the largest number should be start with 15, right? So it should be 1 plus, and the largest number start from 15, so it should be 15 plus 14 plus 13 plus 12, and then plus blah 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 plus 1. All right. So the early part is 1, the later part is equals this part. This part is just 1 plus 15 times 15 divided by 2, which is 15 times 16. 15 times 16 divided by 2, which is equals to 15 times 8, or 330 times 4, which is 120. So this whole number, when it was added to 1, which is we'll get 1 to 1. So the answer is 1 to 1. It's just as simple. The answer is 1 to 1. All right. So this is actually a very simple pattern. Okay, next question. 23. A hypothesis of a right angle triangle is 32. Find the maximum area of the triangle. Now, let me draw again for maximum area. Now the hypothesis is 32. If it has a maximum area, again, every time we see maximum area, we know that this must be when its length and height are the same. So it must be a isosceles, it's a right angle isosceles triangle, right? It's something like this. It must be a right angle isosceles triangle, something like this. This is a right angle. So how can we calculate a right angle isosceles triangle? By just using hypothesis. Simple. Because we can now using three more of it to combine it to form a square. We use 3 more of it combined to form a square. This is a square because the middle part, they all are right angle, so that it actually can form a point. And all it has is a square with length 32. So we know that the maximum area must be equal to 32 times 32 divided by 4. It's because it is just 1/4 of the whole square. So the answer is equals to 256. This answer is equals to 256. And you can find out that the two of them is actually this 1/6 and a root 2, but that's not important. All right, this is question 23. Question 23. Question 24. Now we have a cube with a length 1. How many of them? 2020. If we want to make a solenoid, a cuboid, or what's the smallest total surface area? Again, if we want a smallest parameter, we want the length is as closest together as possible. All the length, width, and height must be as close as possible. again. It must be close together. So, but we know that these three numbers must be multiplied to 2020. But what is the factorization of 2020? It is equals to 2 to the power 2 times 5 times 101. Now, since 101 cannot be decomposed further, so we know that, oh, there's impossible. So we need one to be 101. But the other two must be as close together as possible, right? So we want one to be 5 and one to be 4 so that it will be as close together as possible. So now then we can calculate the area of this, the surface area of this. So the surface area is equal to 101. The surface area would be equals to 101 times 5 plus 101 times 4 plus 5 times 4, and then it multiplied by 2, right? So then we can now calculate it together. So we get this is 505, this is 44, this is 20. So this part when added together, which is equals to 929. And then we need to multiply by 2. It will get our answer, which is equals to 1858 is the smallest area. Is the smallest area, surface area. Okay, this is the smallest surface area. All right, now let's go to question 25. Choose 3 digits with repetition of all this of a construct 3-digit number. Of all these 3-digit number, how many of them are divisible by 9? If we have a 3-digit number, if we have a 3-digit number, how can you make sure that it is actually divided by 9? We add up all the digits, right? Add up all the digits and make sure that the digit is actually equals to a multiple of 9. So, but then how can you make sure that all this number can be written as a multiple of 9? If you think about it this way, then you suddenly realize that it's not much way for you to do this. Now, one way to do this is 999. If all 3 numbers are the same, then it must be 999 or 666. If this number are different, then you can, well, sort of 990 or 900 is okay. But other than that, all the things are going to pretty rough places, because now we can only do something like this is 477 or 468. These 6 are all we have. These 6 are all we have. But the answer is not 6 because we can rearrange number. For example, in this 990, we can rearrange it to let it to become 909. All right. So after rearrangement, this would turns out to have 2 numbers. One is 990, the other is 909, right? All this 999 and 666 will only give you 1 number after rearrangement. Again, this number after rearrangement will get only 1 number. It's just 900. There's no any other numbers. For 477, after rearrangement, we will get 3 numbers, which is 747, 774, and then 477. Well, the last one will have 6 rearrangement, which is 862, 864, 846, 648, 684, and then 468, 486. 6. I don't list them together. So combine all together, we get it. The answer must be 1 plus 1 plus 2 plus 1 plus 3 plus 6, which is equal to 14. 14 is our answer. All right. So this is the question 25. This is question 25. All right. Okay. So now next, going back to 60. 60 cards are marked from 1 to 60, and 2 are drawn at random. Find the probability that 2 cards drawn are both a multiple of 2 or 5. If both a multiple of 2 or 5. So let us ask, if we draw one of them, what is the probability that how many cards are there which is of multiple 2 or 5? Well, because we know that the number of multiple of the number within 1 and 16, which is of multiple 2 and 5, then we can calculate it as the following. The multiple of 2, which is have 15, plus the multiple of 5, which is we have 12, minus the multiple of 2 and 5, which have 6. So we get it, it is equal to 36. We have 36 number, which is of a multiple 2 or 5. So we need to draw 2 of it. We need to draw 2 of it. So the probability must be equal to 36 divided by 60 times 35 divided by 59. Remember that because after we draw one of them, this next one will have less probability. So the answer is actually equals to 59 over 21. It's just like this. Okay, it's just like this. That is 26. All right, let's go to 27. Now roll a dice 4 times. What is the probability that their multiple is 2 or 5? If their multiple is 2 or 5, that means that at least one of them is 2 or 5. At least one of them is 2 or 3, multiple of 2 or 3. Multiples of 2 or 3. But if you think about it, there are many, for a six faces dice, most of the dice are actually have being a multiple of 2 or 3. There are only 2 numbers, 1 and 5, which is not a multiple of 3. So let's ask the opposite. Can we roll, what's the probability that we roll such that this does not get 1 of 5? It does not get 1 of 5. It always get 1 of 5, such that it does not get a multiple which is of 2 and 3. So this must be equals to, because row every time it's only 1/3 of its probability to be rolling 1 to 5, so that every one of them is not 1 to 5 is equal to 81 over 1. So hence our target, the probability is equal to 1 minus that, which is equal to 80 over 81, which is 80 over 81. All right. It's 80 over 81. Now the answer is wrong because we are talking about its multiple, not its sum. So this is wrong. The true answer is 80 over 81. Okay. Now I will sketch through. Now the question 30 is actually the same as our question 30 is the same as our, no, okay. Question 2. So question 30, we will not spend time of it. Please go back and check the question. Please go back and check question 2. I will give you the answer. The answer is 1110. 1110. Now, and then we will now please go back and look at how can we do it in question 2. Now, for question 28 and 29, 28 first, find all three-digit numbers such that its last digit is bigger than its highest digit. We can list them out all together. So the last digit was bigger. So if the 100th digit is 1, the last digit can only have how many possibility? They can only have from 2 to 9, which has only 8 probability. So this is only 8. And the central one was always 10. So for if the first one is 1, it has only 80. If the first one, if the 100th digit is 2, it has only 70, because this is have 10, there's only 7, so this is 70. So we know that this answer must be 80 plus 70, 70 plus 60 plus 50 plus ... to 10, which is equals to 8 plus 9 divided by 8 plus 9 divided by 2, which is equal to 360, right? So the answer is 360. We have 360 three-digit numbers such that its last digit is greater than its first digit. So this is question 28. Now, at last, question 29. Question 29. How many ways are there to split 232 of equal group? Because they are splitted as equal sizes, which means that 2020 must be equals to the size times its number of groups, right? Number of groups. But that means that size is actually a factor of 2020, right? It must be a factor of 2020. So if we write down its factor 2020, which is equals to, as we all know, it is 2 to the power 2 times 5 times 101. So according to the formulas that we previously introduced, which the number is equals to 3 times 2 times 2, which would be equals to 12. All right. So here we have finished the whole paper. Now, question 30, please refer back to question 2. So because we do not have much time to do this. So now we have finished the whole paper. Do we have any more questions? Do we have any questions for this paper other than question 30? If no, then here comes the end of today's lesson. Here comes the end of today's lesson. Thank you very much for your attendance. Thank you very much for your patience. I know that I'm running a little bit longer than it should be, 7 minutes longer. Thank you very much, and I hope you will be doing a great job in the examination. Thank you, thank you, thank you.